Consider the following differential equation. Which one of the following statements is correct? Is it a linear differential equation? Is it a nonlinear differential equation? Is it time invariant? Is it a second order partial differential equation? So there are several things that you could be confused by. The first thing, is this a linear differential equation? Well, it may seem to you that this is not the case because we have t squared, but actually a linear differential equation simply means that all the derivatives are raised to a power no higher than 1. Okay, we have the second derivative raised to the power of 1, and the first derivative raised to the power of 1, and the signal itself is raised to the power of 1. We don't have any function of the y signal raised to a power higher than 1. So this is indeed a linear differential equation. Is this a nonlinear differential equation? So as we mentioned, no, this statement is not correct. Is it time invariant? So by looking at this expression, we can see that the value of t squared multiplies the second derivative. So this differential equation is very much dependent on the value of t on time. Okay, it is not time invariant. It does not do the same. For example, if you look at this differential equation, this is time invariant because time does not appear in this equation. It does not multiply any of the signals. Okay, so this is not a time invariant differential equation. Is it a second order partial differential equation? No, it is not a partial differential equation because the derivatives are only with respect to t. So the solution to this question is that this is in fact a linear differential equation. The solution is A.